Alice, Bob, and Eve explain quantum crosstalk.
Oh, a phone call. Yes? Hello? Hello? Can you hear me? There's so much static on this call.
Sorry about that. I think my new ham radio is interfering with your phone call.
What you're experiencing is actually similar to a major challenge in quantum computing called crosstalk.
Crosstalk? How does my phone interference relate to quantum computers?
In quantum computing, crosstalk happens when operations intended for one qubit accidentally affect neighboring qubits. Just like Bob's radio is unintentionally interfering with your phone call.
In classical electronics, we can usually shield components to prevent interference, but qubits are extremely sensitive and closely packed together.
Why can't we just space them further apart?
We could, but that creates other challenges. Quantum computers need many qubits working together, and the more spread out they are, the harder it is to maintain their entanglement and control them precisely.
Think of these tuning forks. If I strike one,
The other one starts vibrating too, even though you didn't touch it.
Exactly. That's resonance, a classical analog to quantum crosstalk. In quantum processors, when we apply microwave pulses to manipulate one qubit, the electromagnetic fields can bleed over and partially affect nearby qubits.
it's like trying to whisper a secret to just one person in a room, but others can still hear parts of what you're saying.
So how do quantum engineers deal with this problem?
There are several approaches. One is characterizing the crosstalk precisely and then designing control pulses that compensate for it, like noise-canceling headphones.
Another approach is to use different frequencies for controlling different qubits, like how radio stations use different frequencies to avoid interfering with each other.
Researchers also develop special qubit layouts and architectures that minimize crosstalk or use error mitigation techniques to correct for its effects.
I'm guessing crosstalk gets worse as you add more qubits?
That's one of the major scaling challenges in quantum computing. As we pack more qubits into processors, managing crosstalk becomes increasingly difficult.
It's a bit like trying to have hundreds of musicians play in perfect harmony while sitting very close together. The vibrations from one instrument can easily affect another.
So building larger quantum computers isn't just about adding more qubits. It's about making sure they can all work together without interfering with each other.
Precisely. Overcoming crosstalk is one of the key engineering challenges on the path to building large-scale, fault-tolerant quantum computers.
There, I have turned off my radio. Now your call should be clearer. If only solving crosstalk in quantum computers were that simple.